Hey, welcome to Vector Wonderland, the big geometry notes course. Welcome to part 2. In this part, we will have a look at how geometry notes thinks, and we will make a little snow animation at the end with the help of geometry notes. So, grab your drinks, grab your sweets, and let's hop into the second episode of Vector Wonderland. Hey, quick reminder, if you haven't seen the first part, you can click on the right top on the eye. There we will be exploring how geometry notes works fundamentally. And now in this episode we will work on top of that. So if you haven't seen it, I recommend doing this because this is a beginner course for geometry notes fundamentals. In this whole course we will be working with the 3.4 stable Blender version that came out recently, exactly yesterday. I will be using it with the Blender launcher, which is a free application that you can download for free, or you can also go on the Blender website on blender.org, and here you can also see the Blender 3.4 version or higher, and you can just download it. So let's hop into Blender. And look how geometry notes now thinks. Let's click this little project heist away. And here we are inside of Blender. So let's delete everything, and we want to have our default cube back. We've learned in the last episode, a little refresh, that we can drag this window up here, and here we can go inside of the geometry notes editor. But geometry notes is of course also a modifier. So if we click on new here, I can close this. We can see we have also this geometry notes modifier here, and geometry notes manipulates our geometry however we want. And we've explored in the last episode that if we can add nodes via Shift A or on the top left here, and we can for instance subdivide our cube inside of geometry nodes. But how does geometry nodes now think? So for this, I will be creating a little node tree for you, and then I will explain it a little bit further. So let me create, for this we need a split edges node, which is I believe in the geometry submenu. Where is it? Split edges, not in the mesh submenu. Here, split edges, and then we want to have a set position node. And with the set position, we want to have the normal input. So I'll just search it into the normal. And now this is what we get. And let me explain what geometry nodes does here. So we have here our group input, and our group input inputs us our mesh data that we had here before in the edit mode, which is the original cube. We can just manipulate it, and you can see things changing also with our geometry node mesh. This data gets imported through our group input node. So the geometry flows inside of these green noodles. You can see it here. And then the next thing it reaches is the split edges node. Here the faces get separated because we need this afterwards. And after this we have a set position node, which is a node where you can change the position of your mesh, your geometry, or if you want to have different positions for your faces, which we have here. And this set position node changes the position of our faces based on the normal. So in this case, it adds the normal on top of the current position. We have also a very interesting thing, which is here the set position. So we have a very interesting situation with the set position node, because there are two data flows inside of geometry nodes. One is the geometry flow, which we can see here on the top. It always goes from left to the right, which is the group output. It goes always from the group input to the group output. The second flow type is the data flow. Those are always indicated by those striped lines. Another interesting thing is if we plug, for instance, here a subdivide mesh node in, we can see a difference. This is because it is not the subdivision surface node, but I can show you that we have information in these sockets. So we can display what data is flowing in our green mesh data, geometry data. So here, if we hover over the socket, so it tells us the geometry on this point is a mesh with 8 vertices, 12 edges and 6 faces. But after the subdivision surface node, we can see our geometry data gets subdivided. So you can see data also on these sockets. We have our normal data here, and this normal just is the force on our faces. So if we add this to our current position, which is the offset, we can see all our faces get pushed in their normal direction. But the normal it's not outputting a data. It's just indicating geometry nodes that it has to use the normal of this geometry that is plugged into here on the top. So the normal doesn't output any data. It's just an indicator. So every node that is red doesn't have any data. It's just an indicator. So what you can think is that this normal has another input socket and it is directly connected to our geometry that is flowing on top of here. Because for instance, we want to have the normal of another geometry. How can we do this? We can first of all cut this wire, and you can see the set position node just adds a value on top of our position. And how can we now use the normal of another object and how we can add this to our cube? So for this, we want to go into the add menu and we want to add another mesh. So here we can go into the mesh primitives, and here we can use, for instance, an icosphere. But how can we now use the normal of the icosphere and how can we add this to our offset? Because the normal always uses the geometry that is above here, that is flowing into our manipulation node. For this, we have a node, and it is in the geometry submenu. It is the sample index node, and we can plug the geometry in the mesh into the geometry, and we can plug the normal into the value, but for now we change it to a vector. So now we have this, and we can now plug the value into the offset. You can now see something has changed, but this is because there's still something missing. So we're using individual indices, but we don't want this. We want to have all. So we have to calculate the nearest. So let's use a sample nearest node and just plug it in here in between. And now we can see we are using the normal of our icosphere to drive our set position node. And we can also subdivide our icosphere like this. Now geometry nodes uses the normal of the geometry that is above here from the icosphere, and it uses this on the index of the nearest vertex, and then it outputs the vector, and we are using that vector, so the normal from the icosphere, added on top of the position of our cube. And if we have a bunch of subdivisions, we can get effects like this. But what if we now want to import data into geometry, like for instance a vertex group? How can we do this? Because if we go into the add menu, here in the input, we don't have a vertex group input, or even if we search it, vertex group, we don't have this. So how can we do this? So you can imagine our geometry nodes window as our house. And we want to have something outside of our house coming inside. How can we do this? We need to use the front door. So the front door is our group input. So we have to import something from outside of our geometry nodes inside. We can lay a wire from our group input, and we want to use this on the selection because we want to use a vertex group on the selection of our set position node. So the selection just says on which regions we want to have this node to have its effect. So let me reorganize this a little bit so you can see what I'm doing. Like this, maybe. Yes. And now we want to have information from our vertex group we haven't created yet. So let's turn back our subdivision levels and let's use a modifier. Let's use a subdivision surface set to simple, and let's use it after the geometry node, before the geometry nodes window, and let's subdivide it 4 times, and let's set back our geometry nodes subdivision surface, and let's apply this so we can draw actually in the viewport. Here we don't have a vertex group yet, so let's create one and call it, for instance, strawberry. So you can call it whatever you want. And let's go into the weight paint mode and let's paint a little vertex group here. And also let's paint a little A here. So it's a little strange because we have still the geometry nodes enabled. So quickly disable it. And now we can properly paint. So let's paint an A here. And let's paint a little here. And now we have our vertex group. And we can now import this inside of geometry nodes. So for now, we only laid a wire into our front garden, so outside of the group input. But we now want to have the vertex group on our cable. So how can we do this? Currently, we only have the switch on the front garden, but we want to have a machine to control our switch. So for this, we can use an attribute. So the vertex group is an attribute. So we can click on this little spreadsheet icon. And here we can now use an attribute to drive our switch. So let's use our strawberry vertex group. And we have to, of course, enable this again. So now geometry nodes only works where we have our vertex group. So you can see here, if I'll paint our pattern from the icosphere. So now you've learned how you can import attributes or stuff outside of geometry nodes into geometry nodes, but we can also output attributes out of geometry nodes. How can we do this? You guessed it, out of the back door into the back garden. So this is the group output, because we have to output it outside of geometry nodes. For this, we use the group output. For instance, we want to have our vector output, for instance, inside of the shading nodes. For this, we also have to lay a wire into the back garden, so our group output. And now geometry nodes asks us now in which container this attribute should be stored. So what should be the attribute name? For this, you can call it whatever you want, maybe pumpkin. Maybe like this. It's wrong typo, but anyways. Then we can go into the shader editor. And now we have outputted our attribute. So it's now stored under this name. So I will be going into rendered mode, GPU, so it's faster. And let's use the world so we can see something. Now we can use a new node tree. And how can we now import our attribute inside of shading nodes? this is very simple because we have a node for this. It is the attribute node, like this, and we can plug the color into the surface so we can see what it does. And now we can type our attribute, whatever you have called it. I called it pumpkin. And now we have our data inside of the shader editor. And now we can play around with it. Maybe take a vector math, set it to length, and let's use a color ramp and play around with these values like this. And you can do whatever you want with that. And then you can use this for your geometry nodes. So you can use it in your shader editor like this, and you can play with it. And now, of course, we can also change something here inside of geometry nodes. For instance, we can also hire up the subdivisions. So now also our attribute that we outputted gets updated. And this is how you can output an attribute outside of geometry nodes. And this is how the fundamental things of geometry nodes now work. So now I want to show you a really nice add-on, because this add-on has sponsored this episode. And after this, we will make really cool snow animation with the help of geometry nodes inside of Blender 3.4. So let's stay tuned. So the add-on that sponsored this video is the Particle Library add-on. And this is a really great add-on when you want to use particles in your scene, and those make your scenes very, very realistic and professional. So for instance, if you want to use paper bags, you just search for your effect and for instance use newspaper, and then you only have to click on import, and now you have your newspapers. If you want to have a really nice city scene, you can use that, for instance. Or if you want to have voids, those are really cool effects. So if you want to have birds in your scene like this, you can use that, for instance, on the top here. This is also possible, and those are really, really cool additions to your scene. So if you want to purchase the add-on, you would help me also a little bit out. And with that being said, let's move on with our snow animation inside of geometry nodes. By the way, if you want to be time efficient, here are also weather effects. You can also import snow from in here. So if you want to use this, here is also snow. And let's move on with the tutorial. So let's delete everything, and we want to work from nothing. So where's our cube? Let's delete that. And we want to use a plane, scale it up a bit, and we want to go inside of geometry nodes like this. And on our plane, we want to distribute points. So with Shift A, you can go into the Add menu, and here in the Point submenu, let's go on Distribute Points on Faces. And this node places randomly points on our surface, and we can play with the density, and we can make a snow animation out of this if we randomly move our points down with a math node, loop the whole thing. The second thing we want to have is a set position node, because we want to change the position of our points. With this node, you can change the position of everything. Now we want to have a random Z location of our points. We can do this by, first of all, combining the XYZ. So with this, we can split our offset, and we can split the vectors. And now we can use a random value node set into the Z. And now you can see every point gets a random Z height. But we of course want to have it in the negative direction, so it goes down. And everything we do now is we want to animate the max, so it's going down. And every point that is below a certain threshold gets clipped back on the top. and gets moved down again. So it's a little bit looping. And we can do this with a math node. So just search it, math node, and let's set it to fraction. So this node loops all that we do. And now you can see, yay, it's looping. And how can we animate now this random value node? We also have a node for this. It is the scene time node. And you can plug these seconds into the max. And this is of course upside down. So let's use a math node after this. And let's set it to -1. Minus 0.5 maybe, so it's not that fast. And now you can see this is basically snow animation. And you can of course, so let's use our timeline here. It's of course a little bit offsetted, so we don't want to have it started like this. We are inside of geometry nodes, so we can add here and we can offset the whole thing like this. And you can always on the fly change the density of our snow. And you can also, if you want to have a little wind, you can use another set position node or turbulence. And you can use a position input like this, nothing changes, but we want to have a mix RGB node. And let's use it as linear light, so we can mix a little bit of noise in here like this. And now you can see it's very strange, but you have to move down the factor a bit and also take the scale way down, and of course the detail. Now you can see it's a little bit windy and a little bit of turbulence, and it's really nice. So you can also change the radius of your points with a set point radius. So with that you can scale everything down. And now you can see we have nice snow. This will be it. I hope you enjoyed this little extra of our snow animation. And as said, if you want to purchase the add-on that sponsored this video, you help me also a little bit out with it. And yes, thank you all for watching, and hopefully see you in the next episode. Thank you. Oh, these were a lot of new things we've learned. In the next episode we will look at curves inside of geometry nodes, and we will look at the proximity, how that works inside of this system. So then, without further ado, I hope we see us again in part 3 of Vector Wonderland.